Hello, my dear students. So, in the last class, we have seen with respect to the polymers chapter. Under that, we were discussing with respect to the rubber concept. So, we have seen the rubber can be classified into two types, that is natural rubber and synthetic rubber. So, natural rubber, it is made up of the monomer of isoprene, which is nothing but 2-methyl 1,3 butadiene. So also we have discussed with respect to the one marks important definition called as vulcanization of rubber. So to improve the elasticity and ductility to the natural rubber, the sulfur or compounds of sulfur are heated at about 100 degrees Celsius. So that property we call it as what? Vulcanization of rubber. So this we have discussed in the last videos. So if you have any doubts, you can just go through the last videos. Now we'll continue with the concept of rubber, that is the second type of rubber called as synthetic rubber. Now, as the name indicates, synthetic, it is nothing but man-made or a slight modification in the natural rubber. So, to improve the properties, right? So, synthetic rubbers are nothing but the man-made rubbers where there are slightly modification with respect to natural rubber. So, to improve the qualities of natural rubber, synthetic rubbers are developed. So, what are the advantages of synthetic rubbers over natural rubber? Is these synthetic rubbers are more flexible, these are more tougher, and they are more durable than when compared to that of natural rubber. So examples for synthetic rubber includes neoprene, Buna-N and Buna-N. Now these three are very important examples for your synthetic rubber. So they may ask with respect to the preparation or the monomers or the reaction involved in the preparations of these synthetic rubber. So we'll discuss one by one the type of synthetic rubbers. Now, first type of synthetic rubber we are going to discuss is neoprene. Now, this synthetic rubber, it is the first synthetic rubber manufactured in large scale. It is obtained by polymerization of chloroprene, that is nothing but 2-chlorol 1,3 butadiene. So neoprene, it is made up of the monomer of what? Chloroprene, right? What is chloroprene? It is 2-chloro 1,3 butadiene. It is 2-chloro 1,3 butadiene. So this neoprene is also called as diprene. Now, for competitive examination, they may ask for 1 marks which of the following polymer is also called as diprene. So, diprene is also called as what? Neoprene, right? It is nothing but one of the synthetic rubber. Now, this neoprene is more resistance to the action of oils or gasoline, etc., and also resistance to sunlight, oxygen, and as well as heat, and it is non-inflammable. Right. So these are some of the uses with respect to the neoprene. So the important concept you have to remember is neoprene is made up of what? The monomer called as chloroprene. What is chloroprene? 2-chloro 1,3 butadiene. We will see its preparation or the structure. Now, it is this neoprene is also used in making automobiles and refrigerator parts, insulation, and as well as insulation of electrical wires. Right. So these are some of the uses which we are discussing with respect to neoprene. Now, coming for the structure or preparation of the neoprene, we know that neoprene is made up of the monomer called as what? Chloroprene. Right. What is chloroprene? 2-chloro 1,3 by butadiene. So 2-chloro. So you can see here 2-chloro 1,3 butadiene, right? So when it undergoes polymerization, we get polychloroprene, which is nothing but your neoprene. So chloroprene is a diene monomer, that is it has two carbon carbon double bond. So you can see here at first carbon and third carbon there is double bond. So it is 2-chloro 1,3 butadiene, which is commonly called as what? Chloroprene. When it undergoes the polymerization, it forms what? Neoprene, or commonly called as what? Polychloroprene. So very important students. So for some of the examination, it was been asked neoprene, its monomer, its structure, its alternate name for neoprene is nothing but diprene, right? Okay, we have seen also with respect to the uses of this neoprene. Now, second type of synthetic rubber, very important one, right? So most of the time it is asked in the examination, called as Buna-N. Now this is one of the synthetic rubber which is obtained by copolymerization of 1,3 butadiene and styrene. Now the monomers which are present for formation of Buna-S is what? 1,3 butadiene and styrene. So among these, the 75% composition is of 1,3 butadiene and 25% is of presence of styrene. So these together results into formation of what? Buna-S. Now very important students, remember Buna-S is nothing but one of the type of synthetic rubber The monomer present in Buna-S is 1,3 butadiene and styrene. The percentage composition of these monomers are 75% it consists of 1,3 butadiene and 25% it consists of styrene. Now, what is Buna-N? What does these terms mean? In Buna, yes, Bu stands for butadiene. So you can see here it is nothing but butadiene, and S stands for styrene. So these are the two monomers for Buna S. And Na, which stands for sodium, which is a polymerizing agent. So here butadiene, this is sodium, which is a polymerizing agent, and styrene. So these together all forms what? Buna S. So you should remember in examination also they may ask what is meant by Buna S. Buna refers to butadiene, Na refers to sodium, which is a polymerizing agent, and S is nothing but one of the monomer called as styrene. So this is the formation of the Buna structure. So you can see here n molecules of butadiene, 1,3 butadiene, right? So 1,3 butadiene. So here you can see there is presence of first and third carbon, there is double bond. So this results into reacts with the n molecules of styrene. So these are the two monomers which results into formation of what? Buna. Yes, it undergoes the polymerization. So to form what? Buna. Yes. So Buna refers to what? Butadiene, sodium as a polymerizing agent. Yes is nothing but your styrene, right? So you remember and try to practice these structures, dear students. So these structures are also asked in the examination. Now, the third and most important example for your synthetic rubber is nothing but Buna-N. Now, it is a copolymer of 1,3 butadiene, same as that of Buna-S, and acrylonitrile. Here, N refers to acrylonitrile. So, it is composition is what? 1,3 butadiene is 75% present, and acrylonitrile is 25%. In case of Buna-S, same 75%, but styrene here is 25%. But in case of Buna-N, it is acrylonitrile in the presence of peroxide catalyst. So in case of Buna-S, sodium is a polymerizing agent, and in case of your Buna-N, the peroxide acts as a catalyst. And this Buna-N is also known as parabunan, right? So perbunan, it is also called as what? Perbunan. Now it is resistance to action of petrol, lubricating oil, and organic solvent. Now under Buna-N, very important students you should remember is the monomers, that is 1,3 butadiene and acrylonitrile. Composition is 75% 1,3 butadiene and 25% acrylonitrile, right? Now you can see the structure here. The monomers present in Buna-N is 1,3 butadiene and acrylonitrile. So this is 1,3 butadiene. Same you have seen this one. Now what is acrylonitrile? N molecules of CH2 double bond CH We have seen this acrylonitrile PAN, polyacrylonitrile. We have studied with respect to the initial classifications, right? So the same acrylonitrile is used here. So when these two undergoes copolymerization, it forms what? Buna-N. The double bond is broken down and it results into linkage of the two monomer units. So it results into formation of what? Buna-N. So we have studied with respect to the synthetic rubber. Under that, three important examples. One is neoprene. Second one is Buna-S and Buna-N. So most of the time, students, Buna-S and Buna-Ns are asked in the examination. So hence, please be prepared with respect to the names of the monomers of these synthetic rubber, their structures, right? So which are commonly asked in the examinations. Now we go for the next concept called as biodegradable polymers, right? So before I go for this, I'll just repeat here. We are studied under rubbers, natural rubbers, and synthetic rubbers. Under natural rubbers, we have seen with respect to uh, the preparation of natural rubber and vulcanization of rubber. Then under synthetic rubber, the three types of synthetic rubbers called as neoprene, Buna-S, and Buna-N. Then we go for the concept called as biodegradable polymers. These bio, as the name indicates, biodegradable polymers. These are nothing but biologically which undergoes degradation. That is called as biodegradable polymers. Now, natural polymers such as proteins, nucleic acids, carbohydrates, which control various life processes, are called as biopolymers. Proteins, nucleic acids, or carbohydrates, these are nothing but the biopolymers, which we know already, right? And all these biopolymers are undergoing biodegradation. That is nothing but they are biodegradable. Now, biodegradable polymers are those polymers which undergoes environmental degradation, right? So they undergo degradation, an environmental degradation. So hence they are called as what? Biodegradable polymers. So examples for these biodegradable polymers are like PHBV, PHB, nylon 2, nylon 6. So in the examination, sometimes they have asked, give an example for biodegradable polymers. So example includes what? PHBV, right? PHB, nylon 2, nylon 6, right? So we'll see what are these examples expansion, right? So first one will go with respect to PHBV, right? So what is PHBV? Poly beta hydroxybutyrate copolymerized with beta hydroxyvalerate, right? Here co refers to copolymerized, right? So PHBV is nothing but poly beta hydroxybutyrate copolymerized with beta hydroxyvalerate, which is commonly called as what? PHBV. Now, what are the monomers present for formation of PHBV? It is obtained by copolymerization of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. It is very easy to remember, students. 3-hydroxy is common. It is butanic acid and pentanoic acids, which together form what? PHBV. So we'll see the structure of this. So this is your 3-hydroxybutanoic acid. So 3-hydroxy. Why 3-hydroxy? This is a least number we have to give to the function group of carboxylic 1, 2, 3. So 3-hydroxy butanoic acid, so 4 carbon, and carboxylic acid group is present, so 3 hydroxybutanoic acid, this is 3 hydroxypentanoic acid. So these two monomers undergoes copolymerization to form what? Polyhydroxybutyrate and copolymerized with polyhydroxyvalerate, right? So PHBV is nothing but so poly beta hydroxybutyrate copolymerized with beta hydroxyvalerate. So you can see the structure. So try to practice the structures. These are very important one, dear children, right? So first example we have seen with respect to the biodegradable polymers is PHBV. What is PHBV? Poly beta hydroxybutyrate copolymerized with beta hydroxyvalerate, right? Okay, then we go for the second type example for biodegradable polymers called as PHB. Everything is same. Instead of V, there is only PHB. There is nothing but polyhydroxybutyrate, right? So this is obtained by copolymerization of 3-hydroxybutanic acid. So here only we are taking what? The monomer called as 3-hydroxybutanic acid. Whereas in case of PHBV, 3-hydroxybutanic acid plus 3-hydroxypentanoic acid. But here we are going to take only 3-hydroxybutanic acid. Now this is your 3-hydroxy butanic acid, right? So it undergoes polymerization to form what? PHB, polyhydroxybutyrate. So try to remember the structures with respect to the formation of PHB. Now the last type of example for biodegradable polymer is nylon 2, nylon 6. So it is obtained by copolymerization of glycine along with the caproic acid or amino caproic acid. So glycine we know in amino acids we have studied, there is NH2 CH2 COH, right? So here amino caproic acid is NH2 CH2 5 times COH, right? So it undergoes the polymerization with removal of water molecule to obtain what? Nylon 2, nylon 6 type of biodegradable polymer. So biodegradable polymers have three examples: PHBV, PHB, and nylon 2, nylon 6. So each examples are very important, my dear students. So try to remember the monomers as well as the respective the structures of formation of these polymers, right? Okay. So in the last concept of this, we'll see some of the table column, including some of the commercially important polymers with the structures users are given below. So I had discussed already all these type of polymers, right? So just a glance for you, right? So to understand what are the important monomers present here, what is the name of the polymers and their structures and their uses, right? So you can just go through here. I have given some of the monomers like polypropene, polystyrene, PVC, urea formaldehyde, cryptol or alkyl resin, thiol, right? So monomers which are present here, their respective structures and their uses, right? So these are with respect to some important polymers, right? So and their uses, their monomers and their structures, right? So my dear students, so with this we have come to an end with respect to the concept of polymers. Now this is very important chapter, my dear students. So as I had told in the beginning, question number 37 will be with respect to the polymers chapter, that is for 5 marks. It is very important and easy chapters which you can remember. The thing you should do is you have to practice with respect to the preparations of some of the polymers, their names of the monomers, right? And some of times their users also, right? So with this, I think you have understood the concept of polymers very clearly. So please go through the videos right? So that if you are not understood the concept, you can see and understand again and again. So if you have any doubts, please come back with the doubts and clear your doubts as early as possible, right? So with this, we end up with respect to the chapter called as polymers. We'll start with the new chapter in the next video. Okay, hoping for the best. So I think you understood the concept. So if you have any doubts, you can just please go through the videos. Okay, thank you.